Oh, hey there! In this second episode of the Deno series, I want to talk about modules. If you have used Node before, or any server-side language for that matter, you'll know the gist about modules. Splitting your code into modules can help you keep your project organized or enable library makers to share their work. Browser-side, modules have been available for about 4 years now. Before, developer would add their namespace to the global object, hoping there wouldn't be any collision. Deno implements the ES module specification, which means we're importing stuff, not requiring stuff. Working with ES modules is great because it means that your Deno code can be ported to most modern browsers. This isn't the case with Node. This video is sponsored by me. Alright, let's fire up our editor and write some module. In this demo, I will cover how to export and import modules and how to ensure the integrity of your dependencies. During this session, I will assume that you have a basic understanding of JavaScript and its ecosystem. If you have any questions, don't hesitate to write them down in the comment section below. Before we can play with modules, the first thing I will do is to create a file that exports a function. So we'll create a function that we'll call getUser. This function will make a request to fetch a user at random. For this, we'll leverage the fetch function, and we'll make a request to the random user API, and we'll require to include only the name, the email, the login, and the ID. This will treat as JSON. And finally, we'll extract from the results property one user. So if this file is exporting something, obviously we now need a file to import it. So we'll switch to new file. And from there, we'll say import everything as users from our user file. So we can imagine that users is like an object that contains everything that was exported from the user's file. We can use it like this, and we can access our getUser function. So this will make the request for us, get a random user, and then finally we should have our user. To be able to test this, we'll simply log something to the console. Welcome to username title, something like Mr., Mrs., and the last name, like this. So we can run this file using the Deno run command. This goes something like this, Deno run. Then we have to give the run command the permission required to make a network request. We can do this with the allow net flag. We'll specify the domain that we want to allow. So random user.me. And finally, the file that we want to run. So let's run this. And sure enough, we got our message here. Welcome, Mr. Knemberg. I hope I don't mess this up. All right, so this looks like it's working just great. So now we can imagine that if I can do this from a local file, I can also do it from a remote file. So here I'm only going to replace my path for this URL that go fetch a similar file on a remote server. So I can just bring up the console, type in Deno run, allow net random user.me, and run my file, scratch, and we'll see that my code still works. If we want to confirm that we did indeed fetch from our remote server, we can run the Deno info command using our file, and this will show us that this file the Scratch file, has one dependencies, which is my remote users.js file. So obviously, sometime your remote file might be in a private server. In this example, I'll use a private version of the same repository. And in this case, the solution is to give Deno a auth token that will be passed as bearer to the request. In the terminal, I will define the Deno auth tokens variable where I will paste in my token and the domain that is targeted. Following my command, Deno run, and finally the file I want to run. And sure enough, our code still works. If you spend enough time in the Denoverse, you'll notice a naming convention. Oftentimes, a file that exports all of the API will be called mod.js or .ts, and a file that collects the multiple dependencies will be called dep.js or .ts. So this looks something like this. I'm going to create a new file and call it mod.js in this case. What I will put in this file is simply to say that I'll export everything from the users.js file. So now I have a file that centralizes all of the API that I want to expose to the public. On the other hand, if I was the one who was consuming all these modules, I would create a file called deps.js. And in this file, I would simply export everything from my dependency. This can help when you have a lot of dependencies to have them all centralized in one file. Then you can simply call this file, and especially if you ever use sources that have versions, then if you want to bump the version, you don't have to go through all of your files that uses a dependency specifically. An alternative to this could be to create an import map. It looks something like this. So I'll create a new file and I'll call it import.json. And in this file, I'll simply say that, well, I need the imports key. And I'll say that, well, if you say just IY, this will mean this dependency. So if I go back to my original file where I was consuming the users module, I can replace this now with simply IY. Now the difference is when I decide to run it, I have to specify which import map I am using. So I can do something like this, Deno run allow net still. Then import map and mention the import.json file. And finally, the file that I want to run. And everything still works. Amazing. One thing that's important to mention when using import map is that multiple import map cannot be composed together. So this means that if you are a library maker, you should definitely avoid these, because then it would mean that the consumer of your module would have to add all of your all your mapping into their own import map, and this wouldn't be ideal. I think there will be a solution for this down in the future, but right now it doesn't exist. One thing that is worth mentioning is that every files that you are downloading are then cached on your local computer. So this means that if there's ever a change made to those files, you'll need to tell Deno that they need to reload the dependencies. So to simulate this, let's make a change to our getUser function. It used to simply return the user object from the random user API, but now we'll modify it a little bit. So now we'll say, okay, let's extract from the name property, the title as title, and the last name as surname, like this. So we'll simply be returning a new object that has title and surname. So now I push these changes to my remote server. And so if I come back to this file here, I could expect that user, now I collapse the name object, and that the last name is now surname, like this. So if I were just to run this file again, I would then get undefined because in the version I have cached, title and surname don't exist, right? So we have to specifically say that we need to reload our dependencies. So this will look something like this, where we'll say reload. So now we see that our files were reloaded, and we see that we have now a proper answer. When reloading the cache, you can also be more specific and say that you want, for example, to only reload content from IY and not all of your dependencies. Voila. Alternatively, there's also a cache subcommand. Then you can again say that you want to reload everything for scratch.js. This will empty your cache, and then the next time that you come to run your file, you don't have to specify that you need to reload it because you already did clear your cache. So something you might be telling yourself right now is that, well, that is all great, but if I am to give this code to my coworker or something like that, aren't they at risk of downloading the wrong version? And the answer is yes. That's why Deno also offer a locking system. And so if you need to lock the cache for a specific file, what you do is you type Deno cache lock, then you'll mention the name of the file you want to use. In this case here, we're going to say that we want to write the lock file. We don't want to read it. It is important that if you're using an import map, that you specify it. Finally, you type in the file that you want to target. This will create a new file. You can see it here, log.json, that you can use every time that you want to run your code. When we're ready to run our file, we'll have to specify the log file we want to use. The import map. In our case, the permission to access the network. And the file we want to run. And voila, everything works. But if something happened between runs, you would be warned. Here you can see that the dependency users.js is not compatible with the hash that was in the log file originally, warning us that something is wrong. Up until now, we work with modules, importing local file and remote files. We play with fire by not versioning our dependencies and relying on the integrity check to save us from ourselves. The Deno community also maintains module registries similar to NPM. These registries enforce Semver on all modules. This is essential when dealing with multiple dependencies. We are going to visit 2 registries, but there are more. First on our list is DenoX. The Deno core team maintains this registry. It is simple to use. You can leverage GitHub webhook to publish a module. Next up is Nest. Nest publishes modules to the permaweb, meaning that they are permanent and immutable. They do this through blockchain technology. Unlike DenoX, Nest uses a CLI to publish modules. Using a module from one of these registries, you will notice that the path includes a version number that ensures that your import code is immutable. It also means that you can, in theory, import different versions from the same source. In this episode, we experimented with Deno modules. We also did an overview of the many ways you can publish modules within the Denoverse. On the next episode, I want to cover the many tools that come out of the box when installing Deno. You have a linter, a formatter, a test runner, an installer, a bundler, so much more. I might have to make it a 3-parter. Well, I hope you learned something today. Don't hesitate to come back. If this video helped you, please like, share, and subscribe. It might sound cliche, but it helps. If you can afford it, consider sponsoring the Deno community or myself. The links are in the description below.